Hello everyone, this is Professor Amit Solanki from S&T College of Engineering and Research Center, Yeola. Now today we will discuss the topic of the subject Power Electronics, that is the IGBT. IGBT is the very most important topic for the subject Power Electronics because it is the combination of MOSFET and BJT. Okay. As we told that the IGBT is developed by combining the base feature of the both MOSFET and BJT. That means IGBT is developed with the development are combining the best feature. We are taking the best feature of the MOSFET and BJT. Like P MOSFET, IGBT has high input impedance and free from secondary breakdown problem. Okay. Like BJT, IGBT has low conduction losses, that is on-state losses, and high current handling capability. IGBT has P MOSFET like input characteristic and BJT like output characteristic. That means in IGBT, the input characteristic is looking like MOSFET and output characteristic is looking like as a BJT. And IGBT is also known as metal oxide insulated gate transistor, gain modulated field effect transistor, conductively modulated field effect transistor, and insulated gate transistor. These are the different names of the IGBT, and main name is the insulated gate bipolar transistor. As you earlier told that the IGBT is a combination of the MOSFET and BJT. So in that figure, in that slide, you can see here is the MOSFET. As you know that in case of MOSFET, there are three terminals: gate, drain, source. BJT, there is also three terminals: collector, emitter, base. So IGBT is the combination of these two devices. So now new devices is given by that is known as the IGBT. So IGBT has three terminals like gate, collector, and emitter. This arrow shows that this is the collector, sorry, this is the emitter arrow, or emitter terminals. In that figure, you can see here the physical form, the physical structure of the IGBT. So IGBT is looking like that, this type of structure of the IGBT. In that, you can see here the equivalent circuit of the IGBT. Under this diagram, you can see here the equivalent circuit of the IGBT. That is here is three terminals: gate, collector, and emitter. So this is the MOSFET. As we know that the input characteristic is looking like MOSFET and output characteristic is looking like as a transistor. So already we have combined these two characteristics and given the new device, that is the IGBT. Here is the gate current, here is the collector, here is the emitter. Okay. So this is the equivalent circuit of the IGBT. In that you can see here. Now the internal structure of the IGBT. The internal structure of IGBT is that it's like an P MOSFET. An IGBT has thousands of basic MOS cells connected on a single silicon chip. So this is all about the concept for the structure of the IGBT, like an P MOSFET, and the structure of IGBT is very much similar to that of P MOSFET, except one layer known as injection layer, which is P positive, unlike N positive substrate in the MOSFET. So this is the difference. This is the similarity for the IGBT internal structure. Now we are going to discuss about we can understand the structure of the IGBT, how to IGBT structure and how to their working principle, how it is work. Okay, how to current flow is which path. As you see in this diagram, this is the internal structure of the IGBT. In that IGBT, you can see here, this is the P substrate, we can say that this is the injection layer, N negative, that is the drift layer, and this is the body region. These are the three different regions, and this is the junction J1 and J2. Okay, and now that this layer is called as this is the terminal is collector. Okay, so this terminal is collector terminal, and this is the terminal is gate, and this is the both terminals are emitter. Both are connected. Okay. Now this is the metal layer. This is the metal layer, and this is also the metal. This is also the metal. But in that between, this is the SiO2. It is work as an insulator. We have connected here insulator. So for that, this is the all about the concept of the structure of the IGBT. Now, if we are connecting the battery, through these three terminals like emitter, gate, and collector, so then what will happen? We should have to understanding about the how to current flow from here to here. Our main objective is to flow the current from this point to this point. Okay. So what we do, what happen? If we are connected the battery, then what will happen? As you know that this is the junction J1. Okay. This is also forward bias because P to N is forward bias. This is the junction, another junction. This is the N to P. That means this is the reverse bias. Okay. Now this is also forward bias. In that we can see here the current can flow only forward bias. That means here is the reverse bias, but due to that we cannot, here is not current flow. So for that, what will we do? Because so for we connect the one other battery to this gate terminal. Okay, so we are connecting the gate terminal to this gate and emitter and provide the more voltage to break this region through this junction, because this is the reverse bias. Our main objective is to break this region or break this junction to flow the current. So what will happen if we are providing the voltage? Here is electric field is generated, and due to that there are the majority of electrons are generated, and what will happen? It will force to break this region or this layer, and then what will happen? The current will flow from this to this layer. Okay, so as already you can see here, this is the all about the concept of this working principle of this IGBT. This is also the same structure. Okay, so this is the all about the concept working principle of the IGBT. Now we are going to discuss the VI characteristic of IGBT. As we already discussed in working principle, so this is the circuit symbol for the IGBT. Now we are connected to battery. And this is the input characteristic and this is the output characteristic. So we can say that in that transfer characteristic, this is the draw between IC and VG, that is gate emitter voltage and collector current. So in that you can see here, at that point the current is increases slowly, and after this point breakdown occurs, the current is slow suddenly. Okay. Now this is the output characteristic of the IGBT. So in that you can see here, the output characteristic is draw between the collector current and the VC. So these are the all about the concept of the IGBT input characteristic and output characteristic. Okay. Now if you are seeing here the comparison table of the IGBT, you can see here the device characteristic, power bipolar, MOSFET and IGBT. In that you can see here voltage rating is high, less 1 kilowatt, 1 kV, less than 1 kV, very high. It is the 1 kV. So this is the advantages of the IGBT, having high rating, voltage rating, is the high current rating. In that also current rating is up to 500 ampere. Voltage, input voltage from 4 to 8 volt. Impedance is very high, output impedance is low. Switching speed is medium as compared to MOSFET and bipolar. Cost, because cost is high. So according to that, the IGBT is the combination or best combination of the MOSFET and BJT. Okay. So these are the all about the concept of the IGBT. Thank you so much for watching this video.